Hopefully these try problems went all right for you guys. I'm just going to go over them and make sure that you understand it. Starting with example 6, the vertex is located at -2, -2, meaning that h is -2 and k is -2. Also, the parabola is opening down, which means that I know a is some negative number. In order to determine the exact number value, I need to look at how it's moving. Remember, we want to look either left or right 1 unit. I'm going to move right 1 unit and see how it moves. So it seems like it moves from one point to the next, right 1, down 3, meaning that a is going to be a -3. The function, if it's in the form a being out front, so -3 times x minus h, so I'm subtracting a -2, making it a +2 squared, because it's a quadratic function, plus k. So that would mean that I need to put the -2 here on the outside. The domain, since it's a parabola, is all real numbers, or you could have used interval notation. The range, remember, it needs to be down to up. As the function moves down, it approaches -infinity. The highest point, I have to look at the y value, would be -2 with a bracket. Example 7. The vertex is at 0, -4, meaning that h is 0, k is -4. The parabola is opening up, meaning I know that a is positive. Looking at the pattern, it moves right 1 and up 1, meaning a is a +1. The function, you could put a +1 on the outside, or just go ahead and write the parentheses, because it's understood to be 1. It's x minus h. In this case, that would be 0. And then plus k. So I'm going to keep that negative with the -4. You could have simplified this function as x squared minus 4, because x minus 0 is just x. But this is a perfectly acceptable answer. Domain, because it's a parabola, is all real numbers, or you can write it using interval notation. And the range, remember, down to up, the lowest y value is -4, so I put a -4 with a bracket, and then it's going up towards +infinity, using a parenthesis because we cannot reach that. Okay. I feel like those would have gone okay. What people may have struggled with is the word problems. That's usually what gets people the most. Let's start with this first one here. It says that the path that a diver follows is given by this equation, where x is the horizontal distance in feet from the edge of the diving board and y is the height in feet. What is the maximum height of the diver? So the keyword there is maximum. We know that we call a max or a min the vertex. And looking at this equation, it is written in vertex form, meaning that I can identify the h and k values easily. H is going to be a +4. K is going to be a +14. If I want to know which one is the maximum height of the diver, I need to use either the 4 or the 14. X was the horizontal distance that the diver was away from the edge. Y was the actual height. So Y is the value that I'm interested in, meaning that your answer was 14 feet. Because this is a story problem, you should be including your units. Next, a football is kicked into the air. Its height in meters after t seconds is given by this equation. We have several different questions we need to be answering. I'm just going to start off with the first one. What was the height of the football when it was kicked? Okay, so when you kick the football, it has been in the air for 0 seconds. So we're finding the height when the time is 0. I'm just going to make a note. So when the time is 0, I need to plug in 0 wherever I see t. That would become negative 4.9 times 0 minus 2.4 squared plus 29. If you plug that into your calculator, you would end up with 0.776 meters because the height was measured in meters. Don't forget your units here. Next, what was the maximum height of the ball? At what time was the maximum height reached? So the keywords here is maximum, right? We know that a max or a min is also identified as the vertex. And looking at this equation, it is written in vertex form. Looking at it, I can easily identify what the h and k values are. H was 2.4, k was 29. If we think about the shape of the parabola, it's going to look something like this. It's just a rough sketch, okay, where it's opening down. I know that because there's a negative a value up front. Now, when it hits the maximum, which is 2.429, the height would be the y value, okay? The x-axis, so the x value would represent the time. So this is my time, this is my height. I wanted the maximum height. That would be 29. Let's check and see what it was measured in. That would be meters. And at what time did it reach its maximum height? Well, that would be at the 2.4 seconds, because it says time is measured in seconds. Next, how high was the ball after 2 seconds? Well, this is very similar to the first question. When we wanted to know the initial height, we plugged in 0 for the time. When we want to know the height after 2 seconds, we have to plug in 2. So it would be negative 4.9 times 2 minus 2.4 being squared plus 29. Plug that into your calculator, you would get 28.216 meters. Last question. Was the ball still in the air after 5 seconds? Well, let's plug in 5 and see what we get. When you plug that into your calculator, you should have ended up with negative 4.124 meters. Now, you need to ask yourself, does this make sense? Can the ball have a negative height? Or in other words, can a ball travel a negative distance? The answer here is no.